Have you ever wondered what makes your car move? What's under the hood that brings your vehicle to life? Welcome to the fascinating world of internal combustion engines. These marvelous machines are the heart of every vehicle, converting fuel into mechanical energy, making your car zip down the highway or crawl in peak-hour traffic. They might appear complex, but once we break them down, you'll find they are fascinating pieces of engineering. Why should we understand how these engines work? Well, for automotive enthusiasts, it's like understanding the language of your beloved car. It's about knowing what makes it tick, what makes it roar, and what makes it purr. It's about appreciating the power, the efficiency, and the sheer genius of design that goes into every engine. So, are you ready to look under the hood? To decode the language of your car? Let's dive into the world of internal combustion engines and unravel the mystery behind their operation. To understand how an internal combustion engine works, we first need to familiarize ourselves with its core components. Let's start with the cylinders. Imagine them as the engine's powerhouses. They're essentially metal tubes where the magic of combustion happens. Most cars have either 4, 6, or 8 cylinders, and their arrangement can be inline, V-shaped, or flat. Next, we have the pistons. These are cylindrical parts that move up and down inside the cylinders. The pistons convert the energy from the fuel's combustion into mechanical force that drives the car. Think of them as the arms in an arm wrestling match, pushing and pulling with great force. Now let's move on to the crankshaft. It's a long metal shaft that runs the length of the engine. It converts the up and down motion of the pistons into a rotational motion that turns the wheels. If the pistons are the arms in our arm wrestling match, the crankshaft is the hand that turns the win into reality. Last but not least, we have the valves. There are 2 types, intake valves and exhaust valves. The intake valves allow the air-fuel mixture into the cylinders, while the exhaust valves let out the burnt gases after combustion. They open and close at precise times to ensure the engine runs smoothly. If we were to continue our arm wrestling analogy, these valves would be the breath in and out, the rhythm that ensures a steady pace. Each of these components plays a crucial role in the function of an internal combustion engine. The cylinders provide the space for combustion, the pistons convert that energy into mechanical force, the crankshaft translates that force into rotational motion, and the valves regulate the intake of fuel and the expulsion of exhaust. Now that we are familiar with the parts, let's see how they function together to make your car move. The heart of any internal combustion engine's operation is the 4-stroke cycle. This is a rhythmic ballet of mechanics and thermodynamics, a dance choreographed in 4 distinct steps: intake, compression, combustion, and exhaust. It's a cycle that's been powering our vehicles for over a century, and today we're going to break down each step. First off, let's dive into the intake stroke. This is the beginning of the cycle, where the piston moves down the cylinder, creating a vacuum that sucks in air and fuel. The intake valve opens to let in this air-fuel mix, while the exhaust valve closes to keep it all inside. It's a bit like drawing in a deep breath, filling the lungs, or in this case the cylinder, with the necessary ingredients for combustion. Next up is the compression stroke. This happens when the piston moves back up the cylinder, compressing that air-fuel mixture we just inhaled. Both the intake and exhaust valves are closed during this step, creating a sealed chamber. This compression is like coiling a spring, storing up potential energy that's about to be released. It's the calm before the storm, so to speak. Speaking of storms, we come to the combustion stroke, also known as the power stroke. This is where the magic happens. The spark plug ignites the compressed air-fuel mixture, causing a mini explosion. This explosion pushes the piston down, turning the crankshaft and providing the power that propels your vehicle. It's the moment we've been building up to, the release of that coiled spring. And finally, we have the exhaust stroke. After the combustion, what's left is a bunch of hot gases that need to be expelled. As the piston moves back up, the exhaust valve opens, pushing out these spent gases like a giant exhale. It's the engine's way of clearing the air and making room for a fresh batch of air and fuel. But the beauty of the 4-stroke cycle is that it doesn't stop there. As the exhaust gases exit, the intake stroke is already preparing to draw in a new air-fuel mixture. It's a continuous loop, a never-ending dance that keeps the engine running. Each stroke feeds into the next, creating a seamless flow of power. So, in essence, the four-stroke cycle is a masterclass in efficiency and design. It's a testament to the genius of early automotive engineers, who managed to harness the raw power of combustion in a controlled and systematic way. From the intake of the fuel-air mixture to the expulsion of exhaust gases, each step is a crucial part of the process, working in harmony to keep your engine humming. The four-stroke cycle is a beautifully coordinated dance of mechanics and thermodynamics. But how does it all start? Join us next time as we delve into the ignition system, the spark that sets the whole dance in motion. The spark that starts it all is the ignition system. This vital component of an internal combustion engine is responsible for igniting the fuel-air mixture, initiating the process that leads to the vehicle's movement. Now, let's delve into the details. The ignition system's main role is to generate a high voltage from the car's 12-volt battery and send this to each spark plug. This high voltage is used to create a spark at the spark plug, which in turn ignites the fuel-air mixture in the cylinder. It's like a perfect orchestra, every instrument playing its part to create a harmonious, powerful performance. The ignition system is composed of several integral components. First, we have the ignition switch, which is the conductor of this orchestra, controlling when the ignition system should operate. When you turn the key or press the start button in your car, you're essentially activating the ignition switch. Next, we have the ignition coil, a high-voltage transformer made up of primary and secondary coils of wire. The primary coil receives a small electrical charge from the battery, which it then amplifies into a much larger charge. This high-voltage charge is then sent to the distributor. The distributor, another crucial component, plays the role of a traffic officer, directing this high-voltage charge to the correct spark plug at the perfect time. This timing is key, as it needs to coincide with the compression stroke of the engine's pistons. And finally, we reach the spark plugs, the stars of the show. These are the devices that actually create the spark to ignite the fuel-air mixture. They need to withstand extreme heat and pressure, yet still reliably create a spark thousands of times per minute. Without the ignition system, our engine would be a mere collection of metal parts. It's the spark that breathes life into the machine, turning mechanical components into a roaring, dynamic system. And that's why understanding the ignition system is so crucial. Now let's summarize what we've learned. We've explored the ignition system's role, its key components, and how they work together to ignite the fuel-air mixture, starting the engine and setting our vehicle in motion. Understanding the ignition system helps us appreciate the intricate symphony of parts that make our vehicles move. Without the ignition system, our engine would be a mere collection of metal parts. Now, let's summarize what we've learned. So, we've taken a deep dive into the workings of an internal combustion engine. Having journeyed together through the heart of an engine, this mechanical marvel now feels a bit less mysterious, doesn't it? We began our adventure by examining the core components, each of which plays a vital role in the engine's operation. The engine block, the powerhouse of the vehicle, provides a home for the crankshaft and pistons. The cylinder head, meanwhile, is the command center for the intake and exhaust valves, and the timing belt ensures that all these components work together in perfect harmony. Moving on, we delved into the four-stroke cycle, the engine's rhythmic dance. The intake stroke introduced the air-fuel mixture into the cylinder, followed by the compression stroke, which squeezed this mixture into a tiny space, increasing its potential energy. The power stroke came next, releasing that energy in a fiery explosion that pushed the piston down and turned the crankshaft. Finally, the exhaust stroke cleared the stage for the next performance, expelling the spent gases out of the cylinder. The ignition system, our final stop, is the maestro that orchestrates this incredible performance. The spark plug, a seemingly insignificant component, is the star of the show, igniting the air-fuel mixture at precisely the right moment to maximize power and efficiency. The distributor and ignition coil, meanwhile, ensure that the spark plug receives its high-voltage supply just in time. As we wrap up this exploration into the inner workings of an internal combustion engine, it's clear that this remarkable piece of engineering is the result of countless hours of innovation and refinement. The engine's symphony of moving parts, each performing its role with precision, is a testament to the ingenuity of automotive engineers. Understanding the internal combustion engine not only deepens your appreciation for automotive engineering, but also makes you a more informed car owner or enthusiast. Thanks for joining us on this mechanical journey.